So given some sort of curve f of xy equals 0, an integer point xy is a point on the curve where x and y are integers. Finding these integer points is an important and often very difficult area in number theory. The simplest case occurs where our function is linear and the points are on a line. For example, we may want to find the integer points on the line. Note that as long as 2/3 x is an integer, y will also be an integer. And so if x is a multiple of 3, y will be. But remember, to get insight into mathematics, solve it in a different way. So first we'll rewrite our equation so all our coefficients are integers. So the problem of finding integer points on the line corresponds to finding integer solutions to 3y minus 2x equal to 3. These points correspond to solutions to, which will be, and so these points will satisfy, although we can't pick s and t arbitrarily. So if we substitute these into our equation, we find that and so s equals t, and so our general solution will be, and we can generate some points by choosing values for s. So we could also try to find integer points on a line. Note that if 2/3 x is an integer plus 4/5, then y will also be an integer. So if we let x equal, well, we can't actually solve this the way we solved the first one the first time. But if we multiply to make all of our coefficients integers, we get, and so finding integer points on this line corresponds to finding integer solutions to this equation. But since the greatest common divisor of the coefficients is 5, which is not a divisor of our constant, no integer solutions exist. Does this mean we can't find integer solutions if our two terms have fractions? Well, let's find out. Take a different equation, again multiplying to give us an equation with integer coefficients. And so finding the points on this line corresponds to finding integer solutions to 9y minus 2x equals 3. Since the greatest common divisor of 2 and 9 is 1, solutions will exist, and they'll correspond to the solutions to the congruences, which are and we need to find that relationship between s and t, so we'll substitute those into our equation, and we find and some points. Now, an even more important problem is not just finding integer points, but finding integer points that satisfy some additional requirements. So, for example, we might want to find points in the first quadrant on the line. So again, the integer points will correspond to the congruences, and so we solve them, substitute into our equation, and we can find some points. Now, none of these points are actually in the first quadrant. In order for a point to be in the first quadrant, x and y must both be positive. And so we need our expression for x to be greater than 0, and our expression for y to be greater than 0. Well, these are just equations, so we'll solve them. And this means we'll have an integer point t if t is an integer satisfying the inequality. In other words, it's between negative 2/17 and negative 1/3. However, there are no integers in this interval, so there are no integer points in the first quadrant. Let's try to find the number of integer points on a line in the first quadrant. Again, this corresponds to the congruences, which we can solve. To satisfy our equation, we need and so now to be in the first quadrant, we need both x and y to be positive, so setting x and y greater than 0 gives us so we'll get integer solutions in the first quadrant if t is an integer satisfying the inequality. The integers in this interval are between 0 and 24, so there's a total of 25 integer points in the first quadrant.